after a star died. It's predicted every single day there's a star which dies and sends gamma rays for scientists to use for treatment and other stuff. So, a sun's life. So right here is the average star we have right now. That's our sun. We don't have a massive star since we don't have much helium and hydrogen. So that's our sun. It will end up as a white dwarf instead of a black hole. And all of this is our sun's lifetime instead of this one. So I'm going to talk about how our sun benefits us and all of it. So our sun has many layers. Its core is heated up. It has a lot of heat, and you need 1.3 billion million Earths to fit into this star. So that's Earth compared to the sun. It's really, really massive, and it's 93 million kilometers from Earth. It does not orbit anything. Instead, Earth orbits it. So it's stationary, does not move. So our sun is responsible for holding the planets and changing the weather. So our planets are halted by its gravitational force, and our weather is affected by the rotation of Earth. And if it isn't for the sun's gravitational force holding us, we could have been spinning somewhere into space and something horrible could have happened. Gamma rays. Our sun's gravitational force also protects us from gamma rays from dying stars. Those gamma rays can mess up our magnetic fields in many ways, causing trouble. Also, it's responsible for vitamin D and solar power. Right now, fossil fuels are kind of making our ozone layer to get little cracks. So solar power is a really good way to harvest sun's light for electricity. And vitamin D is essential for human body, for the bones, and for just getting outside and having fun. Also, wind power is connected to weather, which also connects to the sun. And it's just a nice day, like out there to go and have fun, exercise, and all of that stuff. Also, it provides light for the moon because the moon absorbs light and produces it at night. So it provides light for the moon to shine at night too. So the sun's energy is made out of fusion. So helium and hydrogen meet, and when they collide, they move in a fast speed in the sun. So when they collide, they release energy later to be seen as heat and light to Earth. It travels about 8 minutes to reach Earth, which is a really fast speed. Comparing that, we are 993 million miles away from the sun. So solar flares are a release of energy from the sun, and these solar flares right there, it equals billion megatons of TNT, which is really, really, really massive. Also, if comets, they have trails because when they pass near an object or a star, they burn up, releasing gas, ice, and rock. But this solar flare right here cut the trail of this comet right there. So its trail was cut off by this solar flare from our sun. So it's mostly hard to cut a comet's trail, but this solar flare did. And a solar flare can mess with our electricity lines. A solar flare once damaged the solar lines for 10 years. It took 10 years for the engineers to rebuild this place, which was damaged by a solar flare. So the sun produces lots of energy per second. So its energy per second equals 10 million hydrogen bombs, which hydrogen bombs are really, really explosive. So we have, our sun is not the only star out there. There are other suns, like this is the sun compared to other big suns surrounding or Milky Way galaxy. So we can see the sun compared to other massive stars, hypergiants, blue hypergiants, red supergiants, or blue hypergiants. All of those are stars massive than the sun. Our sun is actually considered as a dwarf star, not a really humongous star. Actually, the bigger the sun is the more likely is for it to die earlier. So our sun has lived quite a time compared to other massive stars who die every day. So the bigger the star is, the shorter it lives. So this is the biggest star known. It's VY Canis Majoris. It's the biggest star known by now. They're going to discover some of them later. But this is the sun right there, and that's not even half of it. So yeah, it's really big. So I'll show you a video of our sun compared to other suns. So that's just a comparison of all the planets in our solar system. Then we're going to get to all the humongous stars. The author of this video forgot to include one planet, which is Uranus. So that's our sun compared to Sirius A, another sun. And yeah. So our sun does not even appear in a chart. Compared to other suns, the sun is way off there. It's really, really tiny compared to other ones. So it does not even appear to the top biggest stars. So right here we won't be able to see it because of how big those suns are. So this is the star I was talking about. That's the VY Canis Majoris, the largest known one. So we are not even shown that's how small we are compared to this massive star. And it is a red supergiant. So a plane traveling at 900 miles per hour will take 1,100 years to circle it one time. So that's a pretty long, it's actually a millennium to travel this sun in one time. It's only a portion of the Milky Way galaxy, which we have many galaxies in our universe. So Elias Thomas thought that the Earth was the center of the universe, and it's not. There are other big stuff we don't know about it. Also, there's another theory. It's a theory that's not proven yet, but it's likely to be proven, of another star circling our sun. They say it's called Nemesis, and it's a red dwarf. It's not bigger than our sun, but they say it causes they say it circles the sun. So after kind of 26 million years, it comes and disrupts our asteroid field, which we have, and then causes asteroid shower on Earth. But it's not yet proven, it's still a theory. So we won't watch the video because there's no sound. So every solar system reaches an end after a time. So as I showed you earlier, that's the lifespan of our star. And right now we're right here. We have not reached the red giant phase, because it will take about 5 billion years for this phenomenon to occur. So this is the size of us right now, our sun. When it fuels up, it will become like this. So it will become really big because now it's devouring itself. And so this will be Earth, and that's the sun rising on the morning. So it's boiling everywhere. So comparing to a normal sunrise and after 5 billion years, this is the comparison now and then. So after it heats up and sends dust out into space, the core will remain. It will be, this is the core compared to Earth right now. So the core will be smaller and it will cool off after time because it does not have any energy left. Then it will just become like any other asteroid flying into space. Then there will not be any other sun because no energy is left. So why I talked about the sun? The sun impacts us in our daily life. It impacts our energy sources, where the position of the Earth, and all of that. So right now they're having 20 probes out there examining the sun every time, because not everything can happen there and cause effect on us. Whether we like it or not, the sun has a great impact on Earth today. So thank you for your audience.